Mr. Gazda here, hello. Homework 96, mineral questions. Here's some basic Regents mineral questions, and you need a reference table for this. You want to make sure you read all this very carefully. Glass hardness of 5.5. In which zone would the mineral potassium feldspar be placed? So what you need to do is look here. You need to look here. Potassium feldspar is here. And here's the properties of it right here. Things you're going to be interested in. Harder than glass. It lists the hardness as 6. You have to know glass is 5.5. It says it there. So it would be somewhere in the circle. And then what else? Metallic luster. So the luster for potassium feldspar is non-metallic, so it should not be in this circle. And cleavage. Does potassium feldspar have cleavage? This check mark. Sorry. You see, this check mark here on the cleavage side says that it does. So it needs to be in the harder than glass and cleavage circles, both of those, but not the metallic luster. Therefore, and this is a common sense type of thing, you should determine and figure out that the answer should be D. It's going to fall in this circle. It's both harder than glass and cleavage, but not in the metallic luster circle, D. Okay. 2. State the name of one mineral listed on the minerals table in the reference table that could not be placed in any of the zones. Again, you got to use the reference table, but you got to figure out exactly how to do this. So here, this is the metallic luster zone. This is harder than glass. This is cleavage. So you're looking for something that is non-metallic, does not have cleavage, therefore has fracture, and is not as hard as glass, less than 5.5. Therefore, if you were to do that, now I'm here non-metallic, hardness less than 5.5, and it needs to have fracture. Really, it's just this one right here. If you could see that, this one right here, which is sulfur, is the best answer. Hematite's also an answer, a little harder to arrive at, but sulfur is the best answer, the answer that most people get who get this one right. Sulfur. Okay? This one. 3. The table below shows properties of 4 different minerals. So there's minerals names, you probably never heard of those names before. We didn't learn about those in class. Color, look, hardness all the same, non-metallic luster. The minerals listed in the table are varieties of which mineral. Now, you don't know what flint is and chert, and you don't know what these are. Though this doesn't help. This may or may not help, but really help you is composition. And that's something you need to kind of be able just to figure it out on your own. You need to figure that part out. That's the key. Then you go here. The composition column is here. You would go down and notice that SiO2 is quartz. Your answer here would be quartz, which is a choice. You could check all of these, actually. That's probably what I would do. I'd check garnet, check magnetite, check olivine, check quartz to see which is the composition that is that, and your answer would be quartz. So that's where the multiple choice makes it easier. One of the reasons I don't like multiple choice, but take it when it's easier, take it. Asbestos, you want to read this right here. Okay, one reason for the decline in global asbestos use after 1980 was that it was bad for people's health. This says it leads to health problems. You could say something to that effect. Cause health problems, or bad for people's health, or unhealthy for people, for number 4. 5. What determines the physical properties of minerals, such as the long, stiff fibers of some varieties of asbestos? What causes it to have those such properties? Okay, the answer here is really going to be 2 answers. I'll give you the best one first, the crystal structure. Okay, the crystal structure of how the elements are bonded together in the molecules. The crystal structure, and hopefully you're writing this out in a nice clear sentence. Or you could put the, it's also called the atomic structure. Atomic structure may be a phrase you use more. Or the internal arrangement of atoms, okay, how the atoms are bonded together. The other answer would probably be the chemical composition, what it's made of. Those are the 2 things, what it's made of and how those pieces are put together. That is what determines the physical properties. Too many students just write down some physical properties. They don't really understand what the question is. They just write down physical properties like hardness, streak, luster, and that's not what the question is asking. That's not what the question is asking. Chemical formula is this. State the name of the mineral that's most similar. So you need to go down the list, and it's a lot of searching here, and you're going to come up with talc as your answer. So it's searching here. Some of them are very clearly different, but talc is the best answer. Hopefully this is something you found on your own, was able to get talc. Which property is most useful in distinguishing pyroxene from amphibole? Okay, well it's all about the reference table for this. Pyroxene amphibole. If you look here, what property? Okay, so the hardness are very similar, 5 to 6, 5.5. That's not going to help you tell them apart. They both have cleavage. That's not going to help. Color. They're both black to dark green. That's not going to help. And what's going to help is this. Cleavage directions, okay? This has two directions, 90 degrees. This has basically two directions that are at different angles, not 90 degrees. And luckily, multiple choice, therefore the answer is 4. So we need the reference table for that as well. 8 is review. We need review. This is weather. Sling cycrometer, dry bulb, wet bulb. Dry bulb is 20 C. This is degrees C, 20 degrees C. This is the dry, and the wet bulb is 15 degrees C. What's the key thing we need to know about this? We need to know the difference between them is 5 degrees C. So, I am looking for the dew point. I need to go to the reference table, make sure I'm on the dew point chart. So I'm going to go here to this page, and it is the top chart. It's this one. I have my dry bulb temperature of 20, and with the difference, don't forget this is difference right there, is 5. I'm going to go over differences. This is 4. This column is 5. I'm going to double check. Always check. If you're off one column, you're going to be wrong. 12, and the answer being 12 what? Degrees C is going to give you the dew point. 12 degrees C. That's my answer. 12 degrees Celsius. Okay. 9. What wind speed was recorded at Detroit? Reference table again, page 13 of the reference table. Use this right here. The feathers right there. Long ones are, where's Detroit? Long ones are 10, that one's 5. This is in knots. Answer, 25 knots. That's pretty straightforward, I think. Which city has the lowest relative humidity? This is a little more difficult because relative humidity is not listed on here. You have to look at the temperature and the dew point. Okay, so this one, temperature 67, dew point 65. If the temperature goes down 2 degrees, then you have 100% relative humidity and you'll have condensation. So this must be already pretty high relative humidity because they're close. Therefore, for lowest, where they're furthest apart, we'll have the least moisture in the air. And it's going to be Chicago because this is a 15-degree difference. This is only 9, and then this is 8. So Chicago is the best answer because the temperature and the dew point are furthest apart. Know that concept. Know it if you don't already. Which weather symbol? The type best represents the type of precipitation that is most likely occurring in Utica. So what you want to do, look at these. You got to know the temperature at Utica 67, looks to be cloudy, high humidity. It's probably some sort of precipitation, and you want to look at the chart there. And the first one is snow. The second one is freezing rain. The third one is sleet. The fourth one is rain showers. Well, the first three all involve some sort of freezing. It's 67 degrees. The freezing temperature of water, 32 degrees Fahrenheit. So it has to be 4. It's 4. 12, which statement best supported by the diagram? So this is it's about scratching. Answer here 2. Calcite will be scratched by a copper penny because copper penny is a little bit harder than calcite. Even calcite can scratch calcite. They're both the same hardness they can scratch it. This is a little bit harder. That's true. And the rest of those are all wrong. Okay. 13. Let's do 14. We'll go back to 13. Toward which compass direction is Snapper Creek flowing? So Snapper Creek is here. Snapper Creek is here. Here's my north, south, east, west arrow. And it's either going to be flowing this way, which is like maybe northwest or north, or this way, like south direction. How can you tell? These V's right here. See the V's? They point uphill. Therefore, that's the opposite direction. It must be flowing this way. Best answer, south. Probably south. Maybe southeast. So you could say south or southeast. Either one of those answers will work. 15. Calculate the gradient between x and y. Units must be included in your answer. I'm going to need some scrap paper. Okay, I'm going to use my pencil. If I can find a pencil that works. If I can find a pencil that works. Here's one. X and Y, X and Y. So gradient. No formulas on the front of the reference table. Change in field value divided by distance. So so x to y, the change in field value is going to be the elevation in this case. 3,500, 3,000. What is this in? This is in, it tells you what it's in feet right here. So that's 3,500 feet, 3,000 feet. The change from x to y is going to be 500 feet. And then the distance between them is what you need scrap paper for. So I go like this. I carefully, with a nice sharpened pencil, I mark X, I mark Y. I then put it up to the scale down here, and I realize that that is going to be, that's 1, and these go by, well, 0.1, 0.2. These go by 0.1s, so that's 1.7. 1.7, and that is miles. 1.7. Miles, please. Units are important. Units first. Your units will be feet over mile. And 500 divided by 1.7. Where's the calculator? I saw one somewhere. Calculator. Tell me this one works. 500 divided by 1.7 equals 294.1. It doesn't say what to round to. So you could just write 294 feet per mile. 294 feet over mile. Therefore, for every mile you go this way, you're going down about 294 feet in this direction. If you go in this way, it's going up. The range here, I had a range. The range on this one that was acceptable. If you got anything between, and I think I took this from the Regents exam itself of how it was graded. There's a big range here. I think you shouldn't be too far off of that, but the acceptable range, just to show you how a Regents exam works, would be 277 to 313, and you must have units on it as well. So that's the range, but that's really what I think everyone should get, something just like that. Yeah, that's the best. Let's do profile from A to B. So this is how we do it. We go like this, just to show this again. We mark this, we mark this. I've marked down the elevation. So this goes by 100 feet. It's 100 feet. So this is 3,000, 3,100, 32, 33. This is 3,400. I can confirm it to notice it's one contour line down from here. 3,400 is A. So I want to write that in there. A, 3,400. And then B is, let me see. So this is B is 3,000, and this is downhill up there. So this is 2,900. B is 2,900. B, 2,900. Then I want to go everywhere where this crosses the paper. Here, and I have to see what that is. You pull it away to see I'm going downhill here. So that's 3,300, 3,200. And maybe I want to pull off and see what I'm still. So this one's 32, 31. This is 3,000, the darker one. Pull your paper away often. 3,100, 3,000, because sometimes they start changing and going up. This one here, I realize, okay, I can see this. This is 2,900, and then this is 2,900. So those are going to be my last two. I have B already marked. So then this is 2,900. Okay, and if you can see, right, this is the stream. This is the bottom of the stream valley, basically, and then B is 29. So you're going to have this sheet of paper that looks like that. Okay, and then I put it here. And I got to mark my A and B. It's not marked for me. So I go like this, 3,400 mark A. It says X's. I'm going to use an X and connect them with a smooth curved line. That's key. X, and then 3,300 is here. I'm going a little faster than maybe you will because I'm trying to keep this video to a reasonable length. 3,100 is there. 3,000 is there. 2,900 is right there, and then actually B is right here. Okay, so I have that. Then the key part, connect them with a smooth curved line. And I go like this. I want to make sure I go through every single center of every X nice and slow. Go like this. And I need to make it rounded. I need to go down below 2,900, not touch 2,800. There's no 2,800 line crossing the dotted line here. So that's where it goes like this, down there like this, back up to 29. And that's what it should look like Actually, maybe it should look a little more like this even. Getting it right, getting it like that. Okay? That's what it should look like, your profile. So, homework 96. If questions, please ask me. But there we go. I'm Mr. Gazda signing off.